Hey guys, welcome to 3.5 Limits at Infinity. In this lesson we're going to be redoing limits at infinity. So let's go ahead and begin with part A. Part A, you see that you have a rational function and you're taking the limit as x goes to infinity. If you were to plug in infinity for x, you would get infinity over infinity, okay? Which really does not give you an answer. So let's go ahead and figure out what it is. What do you notice about the degree of the top and the degree of the bottom? The degree of the top is 1 and the bottom is also 1. So they both have the same degree, and the trick was when they have the same degree, you get the coefficients and you divide them. So you get 3 halves is your answer. Or you can do it a second way. You could use L'Hopital's rule. L'Hopital's rule says that anytime you get an infinity over infinity, so L'Hopital's rule says anytime you get an infinity over infinity or 0 over 0, you take the derivative of the top and the derivative of the bottom and then reapply the limit until you get an answer. So you can repeat this process. So let's take the derivative of the top. What's the derivative of 3x minus 1? The derivative of 2x plus 5. And when you take the limit as x approaches infinity, notice that there's no x to plug in, so your limit of a constant is just a constant. And you can do it like that also. L'Hopital's rule is actually a lot more faster. Now, if you know your bottom heavy, top heavy, and same degree techniques, you can use those. Those are actually the most easiest way to do it. But you'll see that in some problems later on in this lesson, you're probably going to have to use L'Hopital's rule. Letter B. Letter B, we have the same problem, except now we're going towards negative infinity. Well, it's going to be the same process, but what is the answer? Is it a positive 3 halves or is it a negative 3 halves? Well, let's think logically. A negative infinity on top over a negative infinity at the bottom. A negative number over a negative number will produce a positive number. So just ignore the negative infinity and you still get the same answer. Let's take a look at letter C. Letter C, we have a top heavy. So top heavy means that whenever you have a top heavy function, your limit always goes to infinity or negative infinity. Depends on what sign the limit is. For example, if I plug in infinity here and an infinity here, an infinity squared will surpass a regular infinity. So that means that the infinity squared will get larger and larger as the denominator gets larger but at a slower rate, which means this will diverge to infinity. Or I can use L'Hopital's rule and show you guys. Take the derivative of the top. If we take the limit as x approaches infinity of the derivative of the top, it's 6x over the bottom. If I apply infinity here, I get 6 times infinity over 2, which is the same thing as infinity. Let's take a look at letter D. Now letter D, you got to be very careful because on letter B, the answer was still the same as letter A. But you're going to see that on letter D, it's going to be the same problem as letter C, but different answer. If I plug in a negative infinity, if I plug in a negative number and I square it, I get a positive number. If I plug in a negative number into x, the number is still negative. So what's a positive divided by a negative? It's negative number. And the answer is still the same because it's top heavy. So it's the answer for this problem here is negative infinity because it's top heavy. The only problem is that we have a linear in the bottom, which means that the sign does matter when you plug in a number in there. Let's go ahead and take a look at letter E. Letter E is what we call a bottom heavy function. It's bottom heavy because we have a degree of 2 and we have a degree of 1, and anytime you have a bottom heavy function, your answer is always going to be 0. no matter what. No matter if it's negative infinity or positive infinity, as you approach it, it's always going to be 0. Now, using L'Hopital's rule is kind of tedious, but I'm still going to show it to you, just so I can convince you guys. If I take the derivative of the top, it's 3. The derivative of the bottom is 4x. Plug in infinity, I get a number over infinity, and a large number in the denominator will get smaller and smaller to 0, which means that it will become 0. Now let's go ahead and take a look at the same problem, but when we approach negative infinity. Okay, well, I just said that it doesn't matter where you're approaching from. All bottom heavy functions will approach 0 no matter what. They always approach 0. Now let's take a look at some other functions here. Now we're going to use the top heavy bottom heavy technique here. The degree of the top is a 1. The degree of the bottom is 2. It's a square, but let's go ahead and ignore the 4. The 4 is very insignificant here. If I approach larger numbers, that plus 4 will eventually not do anything to my large number. So it's insignificant, so I'm going to ignore it. What's a square root of 9x squared? If you said 3x, then you're correct. Okay, so what I did here, because the constant is insignificant, I just took the square root of 9x squared, and because when I approach larger numbers, that plus 4 will not do anything to my number, so I can really say that I have a function that's 2x over 3x, which really just becomes 2 over 3. Or you can use same degree. Notice that you have x over x, same degree, divide the coefficients, and that's your answer. So 2/3 is the answer. Now let's go ahead and take a look at letter H. Letter H is going to be the opposite. This time you have to do the negative 2 over 3. Same technique. The plus 4 is insignificant, so I'm going to go ahead and scratch it out. If I square root 9x squared, I get 3x. But now I'm taking the limit as x approaches negative infinity. So that means that my answer was wrong here. So, no, actually my answer was right. Negative square root of, negative 2/3. Now let me tell you why it's negative. If I plug in a number here and I square it, a negative number squared becomes a positive number. But then when I take the square root of that number, if I just take the positive version, it's still positive. Obviously, because you can't take the square root of negative numbers. So this number is a fixed positive here in the bottom, but the negative infinity made it into a negative on top, which means that it's a negative 2 over 3 limit. Letter I. So this one, you can't see it, so it's not so obvious, but this is a bottom heavy function. Let me explain. Let's go ahead and just take a look at the sine x plus 5. Sine of 5x. Sine of 5x, we all know that the number in front of the sine, here's an imaginary 1, and from your pre-calculus class, this number is called your amplitude. That is called your amplitude. Now, your amplitude is half the wavelength. So, if this is 1 and negative 1, my amplitude will look something like this. So my whole wavelength is 2 from top to bottom. My amplitude is always half that distance. Okay, now let's go ahead and take a look at the x squared graph. X squared graph looks like this. It's a parabola. Now, let me ask you a question. The limit as x approaches infinity of x squared, as x gets larger and larger, what is y becoming? Infinity as well. Now, let's take a look at the sine 5x. As x gets larger and larger, what is becoming of sine of 5x? Well, let's take a look at the amplitude. The amplitude always goes from 1 to negative 1, 1 to negative 1, 1 to negative 1. So really your limit for sine of 5x, it never surpasses 1 and it never goes below negative 1. So you really have two limits. You have 1 or negative 1. So let's go ahead and put both of them to the test. If I choose the 1 over infinity, what is my solution? What is my limit? 0. If I choose the negative 1 over infinity, what is my limit? Still 0. So this is a bottom heavy because a quadratic will always surpass a trig function. Actually, all polynomials will surpass trig functions because trig functions are bounded by amplitudes. Now, you have to be very careful when you're using tangent because tangent does go all the way into infinity as well. So I guess my statement was wrong. Anytime you have a sine or a cosine divided by a polynomial and you're taking the limit as x approaches infinity, you're going to have a bottom heavy. So you're going to use bottom heavy technique and it's going to be 0. If it's any other trig function, you might have to do a check. You might have to plug in some numbers. And that's it for today, guys.